Welcome back. Today we are going to talk a little bit more about functions. Okay, and we're going to see a new type of function today. Generally, you've been dealing with functions that are diagonal lines, and today we're going to talk about functions that are a series of connected line segments. So here, this line right here are these connected line segments, right? So this segment to this segment, this one to this one. This is a function. Now, it's a function because it passes the vertical line test. So if you remember, what we said was that a relation was a function. The way that we can tell a relation is a function just from a graph of it or from the geometric portion is that if we take a vertical line and we pass it over the set of points that make up the relation, right? So the set of points that make up the relation are all the points along these line segments. Okay. So these are all the points that make up this relation. And we said that the way we can tell if it's a if it's a function is we take a vertical line here and we pass it over these the function or the relation. And if at no point in time two dots from the relation line up vertically, then we know the relation is also a function. Okay, so here if I pass this vertical line over and let's say I pause it right here. Well, the point where the vertical line intersects the function is right here. Okay, and there's not two points that intersect the same vertical line at the same time. So here, if I move the function along and I stop it, this is the point where it intersects. So every time I do that, I move the line a little bit and I stop it. There's never going to be a situation where two dots from the relation line up vertically. Okay, so what we say is that this relation passes the vertical line test, so it is a function. Okay, so this is the type of functions that we're going to be talking about today. Now, generally with these type of problems, they don't really give you a lot of information numerically on the x and y axis, but they do ask you to describe what's going on. So this right here is a graph of, let's say a roller coaster park is open from May to October each year. The graph shows the number of park visitors over the season. So the x-axis is time and the y-axis is visitors, okay? And we need to describe what is happening with the park visitors in each part of the graph. So for instance, in this line segment right here, what is happening with the park visitors, okay? Now, again, we're not given a lot of numerical information on the y-axis, but that's fine. That means we can describe it, but we can't be that specific. Okay, so in this portion of the line, you can see that the y value remains the same. So in this portion of the line, the number of visitors was pretty steady throughout this portion of time, right? Let's say that like if this was a month, it was, the number of park visitors every day was the same throughout that. So this right here indicates that a certain amount of people are visiting, but that amount of visiting visitors is not increasing over this period of time. Okay. Now for line segment number 2, the visitors are increasing over this period of time, right? We can see that because it's no longer just a flat segment. Any flat segment, it means that it's remaining the same over time. So the amount of visitors, whatever this was on the y-axis, remains the same. But when you have this diagonal segment, line segment, it means that the visitors are rapidly increasing in this period of time. So going from this, if I were to draw a sort of a dashed line here, in this period of time right here, the visitors are rapidly increasing. Again, we don't have a lot of specifics about how much time this is, but we know that the visitors are in time period number 2, the visitors are rapidly increasing because the visitors, it starts at this y value and it ends at this y value, okay? Now in line segment number 3, the line is still increasing, okay, but it's increasing at a slower rate. So in number 3, it means that the visitors are still increasing, but it's at a much slower rate than in line segment number 2, right? Now line segment number 4 shows a decline. So in this period of time, and again, if I created these dashed lines, let's see if I can get my line segment tool and make a dashed line here. In this period of time right here, let's draw these vertical line segments right here. In this period of time indicated on the x-axis, the visitors to the park are rapidly decreasing, all right? So it's about the same slope in a way. It's actually even steeper than the line segment number 2, and it's in the reverse direction. This is decreasing, okay? And then in line segment number 5, between the periods of time indicated here, so if I drew a dashed line here, so in this period of time here, the visitors are decreasing, but not as rapidly as in line segment number 4. Okay, so we have a steady amount of visitors in line segment 1. Then we have a sharp increase of visitors here. And then the visitors increase, but not as much in line segment 3. The visitors decrease right here, and then they're still decreasing in line segment number 5, but not as sharply in number 4. So if we think about it, like maybe this is so if it's open from May to October, maybe this is representing the springtime, and then in the summertime when when kids are out of school, it sharply increases, the amount of visitors sharply increase. And then over the summer months, it doesn't increase as much. It's still getting to be more every day, but there's still a high amount of visitors, but the increase right here is it's rising up slowly. Okay, so maybe this is the summer months here, where this indicates students who are coming in July. In August, increase a little bit from July, but not by that much. And then maybe this is the fall, so students don't come that much in the fall. And then this is maybe the month of late September to October. So that's a way that you can sort of think about this graph. Okay. And that's all you do with these functions, is that you just, you take each section of the function and you try to describe a situation or try to attribute it to a story about what's happening in different times. Okay. All right, now we're going to do the reverse. We're going to be given a situation and we're going to be asked to graph this situation. Okay, so Mrs. Sutton provides free math tutoring for her students every day after school. All right, so this gives us a little bit more information about the x-axis here. The x-axis is in weeks and the y-axis is students, but we don't really know how many. No one comes to tutoring sessions during the first week of school. Okay, so that's important. No one comes during the first week of school. Over the next 2 weeks, the use of the tutoring session gradually increases. Okay, so we're going from 0 to 1 week. Nobody comes. So here time is increasing, but the number of students going to the tutoring session does not increase. So this is tutoring. We'll just write a title for the graph. And we'll say it's math tutoring to be more specific. Okay? So here it's just a flat line between 0 and 1 weeks. There are 0 students between 0 and 1 weeks, because that's what it says right here. Over the next 2 weeks, so from week 1 to week 3, the tutoring session gradually increases. So again, we have no information about how many students come to the tutoring session. So what we can do is just create okay, let's say that it gradually increases like this. Okay. So between week 1 and week 3, we see this steady increase of students. Now let's say that Mrs. Sutton's students were told that they would have a math test at the end of the 5th week of school. Attendance increases rapidly from week 3 to week 5. So from week 3 to week 5, we have to create a line segment that increases sharper than what you see from week 1 to week 3. So actually, let me recreate this a little bit because I don't have a lot of vertical space up here. So let's say that from week 1 to week 3, it increases about this much, right? And by increase, it goes from 0 students to whatever this is on the y-axis, right? So the students increase by this much over from 1 week to 3 weeks. Now from week 3 to week 5, we're going to have to see a bigger increase here. So if this is the increase from 1 to 3, then we have to go much bigger. So this line segment is going to be bigger than this one. So let's say at the end of week 5, we have this many students. So if we connect it, it's going to be this rapid increase. And again, those line segments don't look as different as I want them to. So let's actually recreate them a little bit. Okay, so there's a steady increase. Let's say that she only has about this many people who come in week 3, and then by week 5 we have a rapid increase. So let's see, it goes up to about this much right here. So there's no students, and then there's a slow increase of students, and then we see from week 3 to week 5 a rapid increase. So you can see that the slope of this line is greater, of this line segment here is greater than the slope of this line segment. So the rate of change is steeper. All right, and that has to deal with the rapid increase as opposed to this gradual increase. Okay, and that's how you draw a line, and that's how you draw a graph of a function given a description of the function. Now let's say after week 5 we have the same amount of students coming and there's no increase. Well, then what we'd see is this like horizontal line segment, meaning that the same amount of students, whatever this is right here, whatever this amount is, the same amount of students continue to come from week 5 onward, but there isn't an increase. So what we'd see is this horizontal line segment at whatever y value lands right here. So this is no increase, but there's also no decrease here because it's not going down. Okay, so hopefully this has given you enough ways to really think about these situations, because you're going to be asked to both describe a graph in this manner and also draw yourself a graph from a description. All right, and that's the end of the lesson for today.